So before we jump in, can I ask each one of you to introduce yourself, what organization you're with, and what you're doing? Probably ladies first.
Hi, lovely to meet you all. I'm Emma from Dry Fiber. I'm a textile technician and I lead their textile innovation. So Dry Fiber is a PFAS-free coating. It's a drop-in technology to replace fluorinated chemistry. It's oil and water repellent. And currently we are scaling in the US with AGC and recently Henkel and Daikin as well.
Mario?
Hello everyone, my name is Mario. I'm CEO and co-founder of Tempora. Tempora is a membrane technology that is different from the coating technology that Dry Fiber is making. We add the membrane, to be clear on that, on how to make porous membranes. And we make them currently out of a bio-based material that can be recycled. We can scale it in Europe and in Taiwan. And so that's our main product right now.
Thank you. Stefan?
Okay. Yes, thank you for having me. Stefan Postner. I have been a scientist working with PFAS since the mid-90s and polymer chemistry since 40 years back, but that's another story. So I will try to add some to this conversation, I hope.
Thank you. So let's jump right in. We're talking about this new PFAS methodology. Can you give us, first of all, a short reminder of what PFAS are and what this new methodology is, and specifically what the difference is between this one and the one that was used or recommended beforehand?
I guess it's my turn.
Yes.
Yes, okay. Well, PFAS, there is an OECD definition since a number of years. And that says that if you have at least one fully fluorinated carbon in a structure, that is defined as a PFAS. So we have quite a number of, I think around 30,000 identified chemicals that could be addressed as PFAS. And of course, we have the fluoropolymers, the most famous one, PTF here. So these test methods that we wrote and we started working, was published last year. The main difference is that the extraction of samples is in an alkaline methanol way. The older methods only used methanol. So why did we do that? With the alkaline methanol extraction, you also release bonded PFAS. And in the PFAS-treated textiles or similar materials, you have quite a high concentration of bonded, what we call side chain fluorinated polymers. They could range from 0.1% up to 1% by weight. So what the alkaline part does is that it cleaves the chemical bond between the matrix and the side chain fluorinated polymer, and it results in the release of fluorotelomere alcohols. This is why we analyze bonded PFAS, and of course non-bonded is a legal requirement in the current and coming PFAS regulations. And I talk mainly in the European Union, but also in other parts of the world. So by only using methanol, we have actually not analyzed these samples properly because we have lost the bonded part. Very short, what are we actually talking about here? Sorry for spending a few minutes on that. We think that we have pure, for instance, a C6 chemistry. The telomerization process provides around 30 to 40% of C6. You have around 20 to 30% of C8, that PFOA chemistry. You have a fraction of C4, that's even shorter, and a certain fraction of C10, even longer than PFOA. So with this method, where you take the bonded PFAS, the side chains, you also get results of C8 and C10, and in some cases the C4. Translated this into quantities, if you have 1% by weight of side chains, that could be around 8,000 milligram per kilogram in a fabric in total. And you can estimate 20% of that content to the C8 chemistry. That's a typical C6 product. So we did that to have a real compliance with current legislation and the coming legislation. And of course, to understand intentional use separately from contamination.
Thank you. So if I were to recap for those of us that are less chemically inclined, with this new methodology, we're measuring not only the PFAS that are coming off of the textile, but the ones that are included or incorporated in the textile. And
Correct.
When you talk about C4, C6, C8, C10, those are, let's say, old school DWR treatments, so water repellent treatments, where we have 10 bonded atoms of carbon and fluorine. So C10 was what was used in the past. It was a very durable water repellent, but we realized there were toxicity issues, so the industry then moved to C8, then C6, and today we're looking at C0, so carbon-free. Was that correct?
Well, PFAS-free.
PFAS-free, thank you.
I was talking when I said 20 to 30%, that's a C6 product.
Yeah.
So what we never left C8, we never left C10. We have less, the concentration of C8 and C10 is lower, and the peak of C6 is higher in the modern products. So actually we get a full cocktail from C4 to C10 on a textile fabric, but in a different ratio.
Yes, and I think this is really important because we're now seeing textiles that are treated with supposedly C0 or C2 coming up positive when they were negative on the old tests. And this is what is exactly what is happening. All the side chains, so the side reactions and things that shouldn't be in there are actually still in there. And so we still have C6 when we're not officially supposed to. And this is why brands are having problems with this. And that's why we wanted to have this discussion looking at this new testing methodology. And this is exactly what I wanted to talk about. We've seen companies with products that used to pass tests with around the presence of PFAS, and these same products no longer do so. Emma or Mario and Stefan, do you have any suggestion or approaches for this, for the brands to not have these problems?
Yeah, sure. So for me, it's the brands really need to strengthen their relationships with the mills and go deeper down the supply chain. I've worked with brands previously, and for me, that was the only way I could really have secure, traceable information that I knew was correct, ultimately. Because I find sometimes there are some mills who'd give me a piece of information or assure me of something else, but when you do a deeper dive on their compliance, that wasn't the case. So I think it's really connecting with your materials and all their vendors if they're not vertical, and really understanding the whole process, really.
Thank you. Mario?
Yeah, I want to pick up on the last sentence. The understanding is my key point that everyone should focus on. Understand what you're buying, understand what you're sourcing, and ask questions about what it precisely is, because now you have the understanding, you can also understand the answer and answer back on the specific solutions that you actually source. So you're not getting a PFAS-free DWR that in the end still was a C6 mixture, as Stefan talked about. So understand what you're using, and with this you're in the position of power to decide on what's going to be in your product, and then there shouldn't be any surprises if there are any measurements done on it.
Thank you. Stefan, anything to add?
Yeah, if possible, switch to they're called C0, but there are of course technical challenges to do that. which I guess we will talk a bit about in a few minutes. But the commercial alternatives are increasing the ways to replace PFAS. For the most demanding technical products, that's still a very big challenge.
Yeah. And so we're seeing brands using DWRs a lot. And there is a question that comes up regularly is why do companies put a DWR on a lot of products? We see it on shorts, we see it on pants, leggings. It seems there's this push and pull between should I put a DWR on it or should I redesign it and use another fabric? Is there what's cheaper? Is it cheaper to actually use a DWR and simply spray it, or is it better, or is it cheaper to use another fabric? How do we see and why do we see this still heavy use of DWR in most products?
Yeah, that's a good question. So I'll begin with the application of DWR is very agile. You can apply that across multiple different types of fabrics, weights, compositions. So if a mill produces a particular 4-way stretch fabric, a brand can say, hey, can we add a DWR on that? And 9 times out of 10, if they can, they probably will, with a small amount of cost added to that. So there is always a cost involved. But should brands do that? I think we've kind of touched on this. I think we'll go a bit more deeper in the sense that I think brands add DWR because it's another tech thing they can add to their marketing of the product. But actually, it's probably not needed most of the time. And when I've worked with brands inside, I usually find there's a lot of designers or head of product development who say, okay, let's just add a DWR. Let's just add a DWR. As if it's going to elevate the product. They can put a bigger price tag on it. But you're still just moving away from what the actual product can do, where maybe you can actually replace the fabric with something like Dimpora, or it's just not even needed that performance in the first place. So it's a question of, can we create a system where maybe DWR is only needed for very particular products that are sort of very extreme hiking situations, or maybe PPI, and if things like sort of casual apparel, and we're almost re-educating our brands and our consumers that it's just not needed in most cases.
Yeah, thank you. Mario?
Yeah, I think that the consumer has gotten used to so much functionality in each piece that in the end was added through a DWR PFAS-based, because smoothness, touch, some of the drape as well, was just added by not engineering the product as you propose, but adding a little chemical coating on top, in the product, and then suffering all the negative consequences by PFAS that we don't see, that we don't feel immediately, but profiting from a little bit of technical advancement. And go back to the understanding side, understand what you actually need, what actually your customer needs, and applying what is needed for each product group is the way to go in the future. And having the new test to see where we probably find substances that are toxic and weren't needed in that product at all, helps us to go there a bit faster.
Yeah, I think it's interesting, this DWR everywhere, because if you think about it, most people will only use their urban rain jacket in between the car and the store, or the car and the office, or the underground and the office, or the conference. Then you'll have a second category of users, which are generally most people. They'll go hiking or skiing, and when it starts to snow or when it starts to rain, they go home. And then we have, as Stefan and Emma mentioned, these very high use or very extreme use cases that would actually really benefit from a durable DWR that would really help them. And it's interesting that we don't really see that. I think the cost and the simplicity of, as you've mentioned, it's really easy to spray on a DWR like that. But I'd love to see some suggestions to brands and from brands on the market around that approach.
I think there is even a little bit of an inverted correlation between the people that might use the functionality of the PFAS that we have been using in the high performance space to their understanding of the product, and they could actually, as there are products where you apply your DWR treatment with a wax yourself, and you do that on a regular basis, and you take care of your garment, or you do that with an impregation spray that is PFAS-free, these people that need it and use it, they are very much aware of it and don't use the kind of general applied PFAS-based DWRs. And the ones that just don't have that much understanding on the consumer level, which is absolutely fine, have been fed PFAS-based solutions and are using a product that they're not necessarily needing. So it's not really correlating with the use case and the understanding of the consumer where it's applied and where it's not. So I think, again, also understanding your supply chain, but also your consumer, helps you, again, to select where to apply it and where it's actually needed and where it's not.
Okay, so from a practical point of view, can each one of you maybe give us a short explanation of how your technology, whether it's your spray-on application or your membranes, help brands tackle this PFAS and DWR issue?
So to begin with, we are PFAS-free, which kind of allows us to work across different products and different brands who want to stay compliant and regulated. But our repellency only goes so far. So I'm still getting brands who are coming to me saying, I want a C6 equivalent, I want a C8 equivalent. And the chemistry, unless it has fluorinated chemistry within it, physically can't get to that level. The physics won't allow it, that contact angle of that water, of that oil, to reach 135 on like a level, up to a level 3 on oil repellency on the 14419 test.
Hold on.
So, oh, sorry.
135, 14419 test.
On the oil repellency
lost.
test, and the oil repellency test and the spray rating test, we'll get rid of the figures.
Okay.
So actually, we're then having conversations with brands saying actually using a C5 for a single jersey cotton T-shirt, a C5, a level 5 oil repellency for a cotton jersey T-shirt, does it need to have a level 5 oil repellency? And that is, I think it's jet engine fuel level. So now we're trying to educate the brands, I think maybe not the word educate, but raise the awareness that actually, if they can actually lower their oil repellency standards to that maybe of a level 1, which is a roughly like white spirit level, and you're still going to have a really great product. It's still going to have a stain release to it. It's going to work across all vegetable oils and condiments, which is what a lot of people spill on their T-shirts. So I think there's like a push and pull for them to understand that the standards they already have are just not needed. And it's probably just the lack of the awareness for some people I chat to. They just didn't realize what the levels of oil repellency and water repellency actually equal to on the testing standards. Because I'm having a lot of people who are surprised that their level 5 oil repellency actually meant jet engine fuel. And a lot of them just didn't realize that. That was just a standard they'd always worked towards.
So an education problem to start with.
Yeah, exactly, yeah.
Mario?
For us, the solution was moving a little bit from the chemical kill-it-all method of PFAS to a more mechanical control of sizes and other more benign molecules, bio-based molecules, to create the same function but control it over processes and mechanical ways and size control, which sounds a bit more complicated, probably is also a bit more complicated, but now we have solved it, so we can switch there and we can provide a solution that doesn't require the PFAS on the membrane level and still provides enough protection for all the cases that are like in the normal range, like a distribution. Always the fringe cases, as you mentioned before, certain protective wear and so on, we might have to discuss, but in the broadest cases, the mechanical ways of approaching it and doing over normal chemistry in the right way helps to solve it.
Thank you. But we're sat here talking about waterproofing, and the term oil repellency keeps coming back up. Stefan, maybe you can give us an idea of why do we need oil repellency and how does that work with waterproofing? Please.
Okay. I would like to introduce two terms here.
Yes.
Necessary performance and normal foreseeable use of the product. These are also legal terms. And if we understand that better, we'll find that in many cases PFAS is not needed. That's one part. And what you say about waterproofing, that is more a structural problem than a chemical problem. For doing waterproof, you need microporous membranes that balance and control the flow of liquids, normally water and vapor. So that is a completely different challenge. So what has happened also on the market when I will not mention brands here,
Yep.
but some have a microporous membrane on the backside, or this monolithic. That's another version of membrane, the competitor to microporous. Okay, and on the top you have different water repellent treatments that could be non-PFAS or PFAS. But the non-PFAS, PFAS on the outer layer is not critical for the water resistance. That is the membrane.
So what you're saying is waterproofing or something being waterproof and having a DWR treatment is two different things.
Yes.
Okay. So the waterproofing is, or something being waterproof is a mechanical, structural property, and the DWR brings something else.
Yeah, you could say that. Very
We're simplifying.
Micromechanical.
Okay.
Yes.
Yeah.
Yes. It's actually a classical thermodynamics with water, with pressure, temperature, and all that.
Okay. We're not going to go into those today.
No.
Thank you. Yeah. In our previous discussion, we were talking about these standards that brands use to communicate, the 30,000, and you said something interesting about that.
Yeah.
Could you share that again?
Okay. Theoretically now.
Yes.
Because you have this water resistance measured in millimeter water pillar. And what that means theoretically is that you can, let's say you have 30,000 millimeter, that means that you can go dry 30 meters below the sea level. And that is not a normal situation in my view.
No, that doesn't sound very,
No.
I'm using my waterproof jacket to go hiking.
Yeah. Yeah.
Okay.
So, I mean, the intention here, just to put this phrase here, that if you have a heavy rain, for instance,
Yes.
you don't want the penetration of that water. And it has to do with the structure of the fabric. It has to do with the structure of the backside membrane. And if you look into if there is any DWR treatment, this treatment delays the penetration of the water, but it doesn't stop the water penetration.
Okay, thank you. That's clear. So we need to have these conversations with the actual consumers, right? How do we, or where can we, or should we have these conversations with consumers? Do you think it's a brand level? Is it about a general communication about how DWR and how it's communicated is essentially wrong? Mario, Emma?
I think it's mostly at the brand level, because that's where a lot of consumers see these products come out. Again, outside the brand level, it's awareness within other sort of spaces. But I think on the whole, it is brands, because when people want a particular product for a particular event, hobby, what have you, they do have their favorite brands, and then they're usually swayed by the marketing of that brand or like the long-term connection they have with that brand, right? So I think there is an autonomy that the brands will need to take to raise awareness of the performance and what is realistically needed and why it's needed. In that regard, so going back to like the levels of standards that need to shift.
So we're back to levels and standards and testing methodologies that sometimes are not understood by the brands, asking for protection from oil repellency and jet fuel versus for a standard t-shirt.
Yeah, exactly. And again, we can maybe go back to like potential like leveling system of products within brands. So maybe there's certain products that don't need a DWR. Maybe there's next level of products that need like a light DWR, CO standard equivalent, what have you. And then those sort of products that can get people through those rain, through the particular types of weather for X amount of hours. And then you've got like the level up, which is probably more military and PPI. So it's kind of creating potential categories and alongside that awareness of how our products need to evolve into to then be compliant with these new regulations, and of course like our health and the environment.
Yeah, it's interesting because you could put it into a Coke-free and Coke Zero configuration for clothing, and we don't actually see that within the brands.
It's like all or nothing.
Yeah, you have either one or the other. Yeah. So we're seeing this regulation around PFAS driving the changes, but these changes are also linked to new technologies. Do you think there's a link between the regulatory part for the rise of the new technology and the frameworks, or is there more demand from the brands to see something else? Or I remember we were chatting again earlier, and Stefan said, we have no new technology. Can you explain us a bit more that position?
Yes. Okay, I will. I mean, if you look at the chemistries used, the paraffins, the silicones, in short, and waxes, and this. We have also some non-sized structures for hydrophobicity. These are not new. They have, in my view, been around for at least a couple of decades. I think, and I don't only think, the new thing here is that you have a more efficient way to apply these technologies. And many times you need a combination of these technologies to meet your technical requirements. So it's not pure paraffin, it's not pure nanomaterials, not pure dendritic structure. It's a combination to get the required technical properties.
Okay, and do you think we are close to getting the same level of performance as we had with fluorinated technologies, or is it something that we just won't get it or haven't got it yet because nobody's had that eureka moment?
You're asking me, okay.
And Emma and Mario,
okay, yes.
You're all welcome to input on that one.
I can jump on that one first very shortly. As I think was already indicated here, the chemical and physical properties of these chemistries are different. So having said that, you cannot achieve equivalent performance. That's impossible. That's why I emphasize necessary properties. So the company in question understands what are the necessary properties for my product to function. And from that perspective, you can design in this case, the DVR treatment.
In my eyes, it's an iterative process that has now, at least in my closer circles, although I'm working in this field for 13 years now and have been working on PFAS and talking about PFAS all the time, the understanding on my friends' side that are not in this field has been coming up more recently when more of the media outlet also talked about it, not just in textiles, but also one in Switzerland was meat. There was contaminated meat that was blocked from sales because the regulatory body reduced the limits in meat. So the whole subject got to be much closer to their bodies mentally because it was something they consume, whereas clothing you put on and you carry for hours on close to your skin, so it's as dangerous. But this kind of process of you have an input of an information, you work with it, then you have a system following and changing its product by it, and then it goes around, and at some point we will get to a point where a brand can ask their consumer, what do you actually need? And they're not going to say, yeah, I need everything I ever had because it's what I liked, but they will differentiate between, yeah, I need something that protects me from water, but I want it PFAS-free because I don't want to damage myself. And only once we have this detailed understanding also on the consumer side, we can go there and ask. And before that, it's going to be super difficult to demand the consumer to give us a proper answer what they need without them knowing what actually the consequences are in their answer. So I think we're getting much, much closer to that now. And with the standard, it's another step on the regulatory side that helps us show to consumers and ourselves that we have to reduce the use of these materials.
So there's a push-pull in between the regulation and the customers asking for it, and the brands are in the middle still trying to market or sell high performance. And is there a need for education, whether it's about the fluorinated treatments, whether it's actually waterproof, or is it, how do you see that?
Interesting. I think there is definitely an education within that. I think mainly for the brands and the mills conversations, in my eyes, regulation really pushes adoption of technology that has, like Stefan says, has been around for a while, but the adoption hasn't been there because they've really got something that is a lot cheaper and works if not most of the time better, right? Because it's fluorinated chemistry. So I think for me, regulations has always just been a bit the main driver. And then that has to come with education, which then drives the trends and adoption of something, which then comes from the brands to the mills and saying, hey, but this is coming, these regulations are coming in a couple of years or a couple of months. And then the mills are now like, okay, now we need to onboard this because one, regulations, but two, there is now a trend and a demand for it. So I think it's a little bit of both. I think it's like education across all spaces. But I think going back to your original question is like, can I ever reach the standard of fluorinated chemistry? I think you're talking C8 and above. I think it's incredibly unlikely that the physical chemistry can't work between the surface tension of a fabric and then the oil/water drop to get that particular contact angle. Like the physics, it doesn't play out. So it's again, where do we need to apply these products? And then going back to what Mario was saying, raising awareness with consumers that do they still need the same sort of levels of performance? Because it's to have the same performance as fluorinated chemistry is almost going to be impossible to those higher standards. Okay. Yeah, there's always brands are going to keep iterating, and even ourselves, Dry Fiber, will always keep pushing for like the next level up on oil repellency. But there will always be a ceiling because it's not fluorinated chemistry. It's just non-comparable.
Mario? Agreement?
I agree with that. And I think it's actually a big chance for all of us here, but also for the brands here to work on it and get more detailed and more precise and make a product that is actually applicable to a precise destination it's meant to be in, instead of just having it covers all and it can be used everywhere and everything. And in that sense gets boring, and I think we have lots of those products in the current market. They're just the same, they cover everything, they're not specific, they're not excellent in their specific field, they're just there. And I think once we go back to understanding and engineering again, what solutions we want to have, what products we want to have, also the product feels much more valuable for the specific application you have. And that's, in my eyes, the goal the brands could probably work towards a bit more independent of PFAS or whatever, just being more specific again and use solutions that are suitable for this goal.
Thank you. And so if we go back to our original question, which was, how can brands navigate this? It seems to be a question of, do you really need this? But as a supplier, do you feel enabled to ask them that question and to push back and say, you don't need that?
I do it all the time.
Okay, and what's the response?
Hit and miss. I'm too honest. I'll have someone come up to me and say, hey, I need to see a level 5 oil repellency, again, the engine jet fuel. And I'll be like, well, one, we can't achieve that, and two, it's very unlikely we can achieve that without fluorinated chemistry. And I'm like, what are you using it for? So I've really enjoyed these conversations. I think they're very honest and raw conversations, and I feel like those conversations made everyone think a little bit more about their products. I have some people completely dismiss it, and they're like, oh, it's not good enough, this conversation is going to end and walk away, and that's fine. Like that's what they need to do. That's what they need to do. But then I also have brands and other manufacturing partners who are like, okay, let's have a conversation about this. And what's your point of view? Where's that coming from? And how do we work forward together? So I would say, probably about 50-50 split. Yeah.
Mario?
I think many points we mentioned come together in this question. So we have the regulatory pressure that they know that they have to switch to some extent. Now with the standard, we have a better way to measure it. So we are able to check whether they followed the legislation, at least in the areas of the world where they're applied. Then we have the eagerness or the aspiration of the brand to develop something new, something differentiated, something special, something dedicated to the cause, and that makes them curious on how can we now, within the new legislatory space, find this solution. So if you tell them we have something that can help you go there, try it, they're quite happy to do that because that's what they're educated towards, but so far they haven't really needed to use it. And then with these points, we get to a very fruitful discussion on how we can now use a new product into a problem that was solved so easily previously with a bit more work or a bit more dedication and bring out excellent product. So I think we have more than your success rate in pushing back and saying it's not there it's not the same performance anymore. Maybe also because it was more closely related waterproofing to PFAS-free than oil repellency to PFAS-free, at least in the minds of the brands so far.
Okay, and so maybe I can add an extra layer. Like, does the construction of the garment engineering, have any kind of impact on these, not requirements, but performances, the performance they can reach? Where does that come in?
Yeah, absolutely. So even seams, more on a waterproofing side, for a jacket to be waterproof, it needs to be welded, opposed to being stitched, because that reduces the water coming through. So there's a multitude of different construction techniques that brands are already using to optimize their product even further.
And Mario, is that worthy with, because you're making a membrane, so how do you approach that? And in the same way, do you have any engineering or construction requirements for when your customers use your product? So
our job was to get the product that can be like a drop-in solution for them to use, and it's as easy to use as what they had before. And now I think the detailed work on construction comes in if you look at membrane use and you just have the same protection everywhere. Is this really what the consumer needs, or could we actually apply more protection where it's needed and less where more breathability is needed, because usually waterproofing and breathability are counteracting properties. So engineering on the garment helps to bring this excellent product out in the end, but our current offering is a drop-in solution and can replace old solutions one-to-one, and then there is an extra layer in engineering to make it even better and more specific.
Okay, but we're talking about this testing methodology and PFAS, and one thing that struck me, which I really wasn't aware, and Stefan mentioned that, and maybe you can give us a bit more insights, is that PFAS is still allowed and legal in many regions of the world. So is that changing? Do you know what's the reason behind that? We can't hear you. Stefan's trying to talk and we can't hear him. Sorry. Can you try again, Stefan? Nope.
Okay.
Yes, it's working.
What shall I can't hear you now.
We can hear you, Stefan.
Okay, you can hear me. That's okay. You can hear me now?
Yes.
Okay. So what was the question?
About the legality of PFAS in many other regions in the world.
Yes, we have, if you look on the global scale, we have the Stockholm Convention, where a number of old PFAS chemistries, the PFOA, the PFOS chemistry, the longer chains are restricted. And most of these regions, Canada, Australia, etc., have these, China have this included in their legislation. But if you come to the quite recent restriction of PFAS-free, the C6 chemistry, we are quite alone here, which means that if you have, you can still sell these products legally in Canada, for instance, in parts of the United States, not completely, etc. That means with the global chains, value chains, that makes it hard to explain something that is legal in one part of the world and illegal in our part of the world. And I experienced that was why are you dealing with a chemistry that is legal, for instance, in China or Vietnam, or why are you bothering us with that, or even Turkey, which is a big production country for textiles? So the point here is, since the European Union is a very important trade market, adoption and information exchange is key here to handle this challenge. It's not enough that we have regulation. We have to communicate the rationale behind such a restriction like the C6. There are challenges, and that is possible. May I say something one minute about regulation, because I'm involved in that for many years.
Absolutely, please do.
Yeah, okay. Now I'm involved in the broader PFAS restriction in the Swedish team, and I've been involved in the PFOA, etc., back in the convention, etc. And the baseline here, you cannot restrict a chemistry if there are no viable alternatives available on the market. And with the PFA, with the C6, I say the C6 and the older PFOA chemistry, there are alternatives. It was unfortunate with the PFOA, the C8 chemistry, that the regrettable substitution was the C6, but now with the C6, there are non-PFAS alternatives for many applications, not all, that since the market has shown in consultations that these alternatives exist for various applications and manage the necessary requirements for these applications to work, mainly consumer products, then a restriction is possible. And this is exactly how we work now with the broader PFAS restriction. And that there will be no 100% phase out, because you have the most challenging applications, technical textiles, certain membrane applications, medical devices, where they need more time to switch over. And we find a little piece on the market of applications where this is, I wouldn't say impossible, but extremely challenging. So this is the situation, and I'm very happy that the majority of PFAS applications, and especially when the draft of the broader PFAS restriction proposal was presented by ECHA, there's something happening in companies, definitely. I'm very happy about that.
So legislation is really helping us go forward. But we're back to one essential conclusion, which is, what is it you want to achieve and what level of performance is needed for your product?
Can I put this in euros?
Sorry?
Can I put this in euros, in economy?
Yes.
If we didn't do anything about PFAS, we would have, over 20 years, costs of more than 1 trillion euros to recover the environment.
Yes, if I remember correctly, it costs about $20 or $30 to create or make 1 kilo of PFAS, but it costs 20,000 or something like that to do the remediation. Is that the exact order of magnitude? Yeah.
Yes, with those quantities we are talking about, because in the socioeconomic analysis, they do these emission cost considerations. We are talking up to trillions if we don't do anything.
Okay, thank you.
Yeah.
Is there anything else each one of you would like to add, something that we haven't said that you feel strongly about?
I would like to double down on that. We have a solution that we can replace PFAS with it, and we are open to showing it to everyone, even after the show and next shows. And that we really, really appreciate the work of Stefan and everyone that was involved on the PFAS standards to push this, and even against quite some headwinds from large corporations not accepting them, pushing them through and getting them into law now, at least here, that we can really base on and work with better solutions in the future, even get better also internally with us.
And so where can people find you on the show?
So we're over in the other hall, R17, and timpora.com if you are heading home soon already.
Emma?
Yeah, I can just champion what Mario and also Stefan was saying. So definitely amazing teams who are working on it and pushing it forward. And again, lowering the, not standards, but like wiring our brains to the performance that we actually need for our everyday wear, I think is really, really key. So if you want to learn more about dry fiber, we're on the stand IN27 in the innovation section, and it's dryfiber.co.
Thank you. Cool. Do we have any questions from the audience? The few stragglers. Oh no. Charles, can you get a microphone?
Hi, I'm Charles. Stefan, this is more for you. It's Charles from England.
Hello.
Good to speak to you again. Quite a straightforward question. What was harder, trying to understand everything around PFAS and how much it affected the environment, or trying to get agreement from all 27 member nations of the EU to support the legislation that you proposed?
I hope I have a good insurance to answer that question. The latter part. Of course, by the end of the day, there are economic interests. So being honest to you, of course, it's a challenge to have everyone on board in the union.
Yeah, thank you.
Thank you.
Oh, Charles, Sophie, please.
I should do this.
Thank you, Charles. I want to go back to understanding this is new legislation that is coming into, that is being implemented or has plans to be implemented. What's the timeline?
So it's not a new legislation, it's a new testing methodology that is now recommended to replace the old one. And I don't have the dates.
It'll be obligatory or not?
Stefan?
You talk about mandatory testing. Look, every test method is not mandatory. This is not mandatory, but there is a close connection to the legal process on restrictions on PFAS. And so it's a strong recommendation from ECHA and eventually the Commission to apply these test methods as we see with this updated 2025 version.
Hold on a second. We have an announcement, sorry.
Every visitor, exhibitor, speaker, partner, and sponsor for a successful and friendly experience. To all exhibitors, please do not fully dismantle all of your booths until 5 p.m. Cars can enter the gate from 5:30 p.m. via gate 21. Thank you.
Okay.
Thank you, go ahead.
Yeah, and thank you. It's okay now. We have the broader restrictions. I mean, virtually all PFAS, independent of chain length, etc., also including fluoropolymers, are suggested. But the fluoropolymers is the total fluorine testing procedure, and that is not this test method cannot catch fluoropolymers. But anyway, if you are really striving for compliance, this test method was designed to do that. So, but there is no one with a test method that can force you to use it. But I would say a strong, forcible recommendation. That is a proper wording. Yeah.
One of the reasons we decided to have this discussions is that we've seen brands come to different consultants and experts and tell us, I have this product, I tested it with the old method, it was great, it passed, and I could sell it. Now I'm testing the same product from the same supplier with the same supply chain, it no longer passes the test. What do I do? What does this mean? And where is this going? And this is where there's choices to be made. Either you redesign it, change the supply chain, or you take that risk of having your product pulled. Is it worth the reputational risk? But it is strongly recommended to use that new testing methodology.
Yeah. Well, I have to add that when the C6 is already in place since 2024 in October, and there will be other actors on the market that will use this test method. So it's a risk, as you pointed out, Stuart, to use an older test method, since you don't get the full picture of a possible PFAS content.
Thank you. And I think that's it, really. We don't have any other questions. Thank you, Stefan, Emma, Mario. We really appreciate your inputs on this and having this discussion.
Thank you, Stuart.
Thank you.
Thank you. Thank you very much. Thank you.